to start looking at how to determine whether or not two triangles are congruent or not. All right, so when two figures are congruent, there is a correspondence between their angles and sides such that the corresponding angles are congruent and corresponding sides are congruent. So basically, if two figures are congruent, then all the things that correspond to each other in those figures should be congruent to each other. All the sides should be congruent to each other. All the corresponding angles should be congruent to each other. And so as we look at these two figures here, we got triangle ABC and triangle DEF. And so in the corresponding angles, A matches up with D, B matches up with E, C matches up with F. And so those corresponding angles should be congruent to each other. And then as far as the sides go, side AB matches up with side DE, so they're congruent. Side BC and EF are corresponding, they're congruent. And AC and FD are congruent to each other and corresponding. So once we know that all the corresponding angles, all the corresponding sides are congruent, then we can say that the two triangles are congruent. Triangle ABC is congruent to triangle DEF. Now, one key thing to recognize when we start comparing triangles and other figures being congruent to each other, when I say that they're congruent to each other, the order that the name of each figure is in matters. Right? If I say triangle ABC is congruent to triangle DEF, then that means that angle A is congruent to angle D. Angle B is congruent to angle E, and C is congruent to angle F. So those corresponding angles, those letters that go with those vertices, have to be in order so that they match up. So anybody that looks at that statement that says ABC is congruent to DEF knows that A matches up with D, B matches up with E, C matches up with F. All right. So here it says in the diagram, ABCD is congruent to EFGH. Find the value of X and find the value of Y. All right, so just like I just stated, if it says that ABCD is congruent to EFGH, then that gives us what corresponds with what. Right? So by following through, A is going to match up with E. And then B and F are going to match up with each other. C and G go together. And D and H then would match up. And notice that 4 different angles being congruent, so the arcs that I'm putting in match up by the number of arcs there, right? So 1 arc goes with 1 arc, 2 with 2, 3 with 3, and 4 with 4. So then you could also use these to determine what sides were congruent to what matched up, right? AB, side AB matches up with EF, and BC goes with FG, and CD with GH, and EH with AD. find the value of x. So the x is in this section right here on the side, which is side AB, which we said would match up with side AB and EF. We're going to go together, right? So those two are congruent. So for A, we got 4x minus 3 should be equal to 9 centimeters. And we can solve, add 3, both sides. 4x equals 12 centimeters and divide by 4. The x value is going to be 3. And for B, we're finding the value of y, which the y is here at angle C, 5y minus 12. And C matches up with G, right? So 5y minus 12 is going to equal 113. Add 12 to both sides. 5y equals 125. Add both sides by the 5, and y equals 25. So you can figure out everything that matches up just by looking at the names. And likewise, when you write down the names of two figures that are congruent, you've got to make sure that you are putting them in order so that they match up with all the corresponding parts in the right order. All right, so theorem 4.3, known as the third angles theorem, says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So basically, if we know that two angles of one triangle are congruent to two angles of another triangle, then the third angles have to be congruent because we know that every triangle adds up to 180 degrees. Right? So if I already know that two of them are congruent, then those two angles added together is going to equal these two angles added together. And so what's left from those to 180 is going to be the same for angle C and angle F. Right? So angle A plus angle B is 120. Angle E plus angle D is 120. Then that only leaves 60 degrees for angle C and 60 degrees for angle F. Just because all triangles add up to the same, 180. All right, so find the value of x. All right, so here we're shown that this angle A is being marked congruent to angle D, and angle B is congruent to angle E. So that means that the third angles, angle F and angle C, would then have to be congruent to each other as well. And so in order to solve for x, we've got a little bit to figure out, but we know two of the angles in this triangle, A and B, are 22 and 87, and those match up with D and E here. Angle F matches up with angle C here, so we know that it's going to be 22 there, 87 there, or we know that this angle right here is 4x plus 15. But either way, to solve for x, since we know what all three angles represent in the triangle, then we can add all three together and set it equal to 180. So 22 plus 87 plus 4x plus 15 has to equal 180 degrees. So 22 and 87, that's 109, plus 15 is 124, plus 4x equals 180. Subtract 124 from both sides. And 4x is going to equal 56. Divide both sides by 4. And x is going to equal 14. You could have also just taken 22 and 87 away from 180, and then what value that gave you, you could set equal to 4x plus 15 if you wanted to do it that way. Questions so far? Anybody? All right. So here we want to decide whether the triangles are congruent, and then we're going to justify our reasoning. All right. So when we look at the triangle, starting off, we got all three corresponding sides marked congruent, right? EF is congruent to HJ, EG is congruent to JG, and HG is congruent to FG. So we know all three sides are congruent, and then we also know that angle F and angle H, both being 58 degrees, so that means that those two angles are going to be congruent as well. All right. So those angles match up to be congruent. And then anybody see anything else that we could come up with that would be congruent in there? All right, if I look at the very center right here, point G, right? We've got two intersecting lines. And whenever we have intersecting lines, we have angles that are created, especially ones that are straight across from each other. Straight across from each other at the intersection are known as what? Vertical angles. Right? And what do we know about vertical angles? Vertical angles are congruent to each other. Right? So I have a set of vertical angles here in the middle of this bow tie figure. Right? And so those, based on the vertical angles theorem, I know that those two angles should be congruent to each other. And then, so now I've got everything marked congruent except for angle E and angle J. But since I've got two angles marked congruent right now, then I can rely on third angles theorem. Say, well, I know if these two are congruent, then the third ones have to be, right? So, by the third angles theorem, we can get that E is congruent to J. So then, all of that is written out for you to copy. It's a little paragraph here, which basically tells you everything that we just covered, right? By the diagram, all three pairs of corresponding sides are congruent. EF was congruent to JH, GF was congruent to GH, and GE was congruent to GJ. Angle F and angle H both had a measure of 58 degrees, so angle F is congruent to angle H. By the vertical angles theorem, angle EGF would be congruent to angle JGH. And we have to give 3 letters on the naming of these angles here, because we can't just say angle G is congruent to angle G, right? There's actually 4 angles made right here at point G, so I can't just say G because we don't know what angles they are. That's when we have to use the 3-letter naming system for those angles. And angle E is congruent to angle J by the third angles theorem. So by the definition of congruent triangles, triangle EFG would be congruent to triangle JHG. Right? And that definition of congruent triangles just says that all the corresponding angles and all the corresponding sides would be congruent if they're congruent triangles. Right? Questions there? All right, so here we have an actual proof. So given that segment MN is congruent to segment QP, and segment MN is parallel to segment PQ, O is the midpoint of segment MP and segment QN. Prove that triangle MNO is congruent to triangle QPO. All right, so MNO is this top triangle. We're trying to prove it congruent to QPO, the bottom triangle. All right, so let's mark all the stuff we can mark based on what they gave us in the given. So MN is congruent to QP. So MN and QP are congruent. And then it says O is the midpoint of MP and QN. And what does it do for them to tell us that it's a midpoint? Anybody know? Oh, we'll come back to that in a second. All right. So I'm going to start off with part of the given. So I'm going to start with these first 2 parts. MN is congruent to QP and MN is parallel to PQ. That's given. Now, the fact that MN is congruent to QP, that doesn't really give us any information that we can use or build upon. That's why I went ahead and brought the 2 parallel lines in here. Now, anytime that it tells us that 2 lines are parallel, we got to start thinking back to the past chapters when we dealt with parallel lines and transversals. In most cases, if they tell us 2 lines are parallel, there's going to be a transversal, and we're going to have to come up with angle relationships that work based on those lines being parallel. So if I look at MN and QP, so these are parallel lines, top and bottom. Of course, we're kind of used to seeing those lines go on further, right? Which also makes the MP a transversal there, and QN is a transversal over here. So if MP is a transversal and these 2 lines are parallel, then we have to recognize that this angle right here, angle OMN should be congruent to angle OPQ, as those are, what's the relationship? Different sides of the transversal in between the two parallel lines. Alternate interior angles. Right. So, and then likewise over here, angle ONM and angle OQP on this transversal are also different sides of the transversal in between the two parallel lines. So they should be congruent since those lines are parallel. So we can state that those angles are congruent. NMO is congruent to angle QPO, and angle MNO is congruent to angle PQO. And that's based on them being alternate interior angles, which the alternate interior angles theorem tells us that those would be congruent. So that angle is congruent to that angle, and this angle is congruent to that angle. All right, so that's got two. So right now we got two angles and one side, congruent to two angles and one side. So then from there, we know that these two are vertical angles. MON and QOP are vertical angles. So by the vertical angles theorem, MON and POQ would be congruent to each other. And then we kind of run out of stuff we can do, so we bring in the other part of the given. O is the midpoint of MP and QN. That's given. And since it's the midpoint means that it splits it in half, so it makes two congruent segments, right? So it's the midpoint of MP. So MO and PO would be congruent to each other, and NO and QO would be congruent to each other by the definition of midpoint. All right, so at this point, we've got all three corresponding sides marked congruent. And we've got all three corresponding angles marked congruent. So since all of our angles and all of our sides are congruent, then we can say, what about those two triangles? That the triangles are congruent based on the definition of congruent triangles, which says that all the corresponding angles and all the corresponding sides would be congruent if two triangles are congruent. So triangle MNO is congruent to triangle QPO. And remember, when we write that statement, it's important that the letters are in the right order so that we're matching all the corresponding parts together. All right. Questions on that one? All right, so then the last thing here, theorem 4.4, the properties of congruent triangles. This is just those same three properties that we've learned 4 times previous. The reflexive property, the symmetric property, and the transitive property. So this theorem is just telling us that the reflexive property of congruent triangles says that every triangle is congruent to itself, just like the reflexive property of anything else that we looked at. Right? Anything's congruent to itself. Symmetric property of congruent triangles. Triangle ABC is congruent to triangle DEF. Then we can switch the order, and triangle DEF can be congruent to triangle ABC. Transitive property. Congruent triangles. Triangle ABC is congruent to triangle DEF, and DEF is congruent to triangle JKL. Then triangle ABC is congruent to triangle JKL.